Hello, Assalamu alaikum. Here is Samar Shahab, your chemistry teacher. Hope you all are safe, fine, and healthy. Today, we have to take a class on periodic table that we have learned on the last class. Okay, we have to just revise some points, and you have to write down in your copies. Okay, the first and the most important point related to the arrangement of the elements in the periodic table is the elements are arranged on the basis of increasing proton number. Okay, so you have to write down elements are arranged on increasing proton number. Periodic table is the arrangement of elements in which elements are arranged on the basis of their increasing proton number. We have learned in previous class. Then I have told you about some features of periodic table. Number one, periods, horizontal rows. Okay, so these horizontal rows called as periods. You can see over here. The first and the last period is shown in the slide. Horizontal rows of the elements are termed as periods. Then groups. Vertical columns of elements are termed as groups. You can see over here the first and seventh group of the periodic table is shown in the slide. Then what is this? You can see over here that an arrow is showing you the presence of hydrogen in the periodic table. It is in the first row. That means hydrogen present in the first period. Okay, and the proton number of hydrogen is 1. And the second arrow, which is in blue color, is showing you the presence of helium in the periodic table. That is showing you in the same row, that means in the first period, but in the another group, in the another column, that is the 8th column of the periodic table. Okay, so periodic table is arranged on the basis of increasing proton number. You can see over here the first element is hydrogen, which is identified by red arrow is 1 proton number. Then helium is the second member of the periodic table with 2 proton number, which is identified by blue arrow. So same as 1, 2, then lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, and so on. All the members of the periodic table arranged on the basis of increasing proton number. And if you talk about periods, so you can see in the slide, the first row is termed as the first period, and in the third row, the yellow elements are termed as period number 3, and so on. Period number 4, 5, 6, and 7. We have 7 periods in the periodic table. Then groups. We have 8 groups in the periodic table. You can see over here, the first column of yellow color is termed as first group. Then this is the second group, third group, fourth group, fifth, sixth, 7, and 8. Okay, we have 8 A category groups in the periodic table. Here is a group number 1, and group number 8 is also termed as group 0. Now, the central part of the periodic table, which is between group number 2 and group number 3, is termed as transition elements. Okay, we remember this. The central part of the periodic table between group number 2 and group number 3 is termed as transition elements. Then you can see over here the yellow part that is on the left hand side is made up of metals. I have already told you in the previous class that the 75% of the periodic table is based on the metals. So you can see in this that the yellow part of the periodic table is based on metals, and the blue part of the periodic table, which is on the right hand side, is of non-metals. Okay, And the staircase, you can see over here the dark black line. All the elements beside this dark black lines are termed as metalloids. Metalloids are the elements that have the ability of metals and non-metals as well. Okay, so you can see over here silicon and germanium are the most commonly used metalloids. Then metallic and non-metallic character. As you know that on the left hand side we have metals, and on the right hand side we have non-metals. So the metallic character, when we move from the left hand side to right hand side across the period, will decrease. Okay, the metallic character of the elements decreases when we move from left hand side to right hand side. You can see over here that is a group number 1 on the left hand side based on metals, then group number 2 based on metals, then group number 3 based on metals. Then from group number 4 metalloids starts. Then group number 5 contain non-metals, 6 contain non-metals, group number 7 contain non-metals, and group number 8 contains non-metal gases. Okay, that means the metallic character of the periodic table decreases when we move from left hand side to right hand side. That means you are moving across the period. Across the period means you are moving onto the period. Okay, for example, here we have period number 3. Third period contains sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are 8 elements of third period. Okay, so you can see over here first member of third period is sodium, then magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay, then we move across the period from left hand side to right hand side. Sodium is the most metallic element. Then the metallic character of the element decreases to magnesium. Then aluminum is more less reactive metal as compared to magnesium and sodium. Then we will have metallite. Then phosphorus is a non-metal. Sulfur is more reactive than phosphorus. Then chlorine is the most reactive non-metal among these 3. And then we have non-metal gas, which is unreactive argon. So the metallic character of the periodic table decreases when we move across the period. You have to note down this point. Okay. Then here we have basic, amphoteric, and acidic nature of the oxides. For example, if we talk about the oxide of sodium, when sodium reacts with oxygen, it will form sodium oxide. When magnesium reacts with oxygen, it will form magnesium oxide. When aluminum reacts with oxygen, it will form aluminum oxide. So these oxides of the elements of third period have its own nature. For example, if we talk about sodium and magnesium, so their oxides are basic. Then if we talk about aluminum, so the nature of this oxide is amphoteric. Then the oxide of phosphorus, sulfur, chlorine are acidic in nature. Okay, so when we move across the period from group number 1 to group number 8, the nature of oxides also change from basic to amphoteric and then lastly to the acidic. Okay, so be remember these points and write down in your notes. First point is from left to right across the period there is a decrease in metallic property. Okay, and definitely when there is a decrease in metallic property, definitely there is an increase in non-metallic property. Okay, and there is a change in in oxides, like from basic to acidic. Between basic to acidic, here we have amphoteric nature. Then groups and periods indicates us the electronic configuration that I have already told you. Okay, if we talk about groups like group number 2, group number 3, group number 4, what does it shows us? Like if we talk about beryllium, so it belongs to group number 2, and we know that if it is belongs to group number 2, that definitely it has 2 valence electrons. Then again magnesium from group number 2, it has 2 valence electrons. Calcium group number 2, it again has 2 valence electrons. Then carbon group number 4, it has 4 valence electrons. Then silicon, 4 valence electrons. Then oxygen from group number 6, it has 6 valence electrons. Sulfur group number 6, it has 6 valence electrons. So the valence electrons can be identified by group number, or a group number can be identified by the valence electrons. Valence electrons are the electrons present in the outermost shell of the element. Okay. Then period. Period can be identified by the number of shells occupied. Okay. So in beryllium, you can see over here 2, 2. That means only 2 shells are occupied by the beryllium. That means it is present in the second period. Then magnesium occupy 3 shells. That means it is belongs to third period. Calcium occupy 4 shells. That means it belongs to fourth period. Again, carbon occupy 2 shells. It is of second period. Silicon occupy 3 shells. It is of third period, and so on. So we remember the number of valence electron in the atom shows the same group. Okay, group number indicates the number of valence electrons. When elements have same valence electrons, they are in same group. For example, you can see over here beryllium has 2 last electrons, magnesium and calcium as well has 2 valence electrons. So these 3 elements belongs to the same group, that is a second group. Okay, and they all have 2 electrons in the outermost shell, therefore they have same chemical properties. Chemical properties depend on the number of valence electrons. So when the elements have the same valence electrons, then their chemical properties will be similar. Then when we talk about the elements present in the same period, they have same number of electron shells that are filled. Now trends. Trends, for example, if we talk about proton number, so within a group, for example, we are moving from top to bottom. Okay, so the proton number will be increased. The atom size will be bigger because the number of shells will be increasing. Then the metallic character will be increases. We remember when we move from top to bottom within a group, when we are moving from top to bottom within a group, the metallic character will be increased. Just write down in your copies, when we move top to bottom within a group, the metallic character will be increased. For example, if we talk about the first group, the sodium, potassium, rubidium, cesium, and francium. These are the elements. So sodium is more reactive, but cesium is the element which is more reactive than sodium. Okay, then definitely francium is the most reactive metal. So when we move down to the group, in the same group, the metallic character will be increased. But when we are moving across the period from left hand to right hand, the metallic character will be decreased. Okay, why this happen? Because when element increases their shells, the last electron from the nucleus will be away. Therefore it is very easy to lose that electron. Therefore the reactivity of the element will be increased. Then you can see over here, when we talk about group number 1 elements, it contains 1 electron in the outermost shell, so they can easily donate that and become +1 charge. When second group members donate their 2 valence electron, they become +2 charge. And when third group members donate their last valence 3 electron, they become +3 charge. This will happen due to complete their octet, to gain the property of noble gases. Okay, they want to be stable, therefore they lost their valence electron to complete their octet. Octet is the completion of 8 electron in their outermost shell. Okay, then 6 group members receive 2 electrons because they have 6 electrons in their outermost shells, so they become -2. 7 group members receive 1 electron because they have already 7 electrons in their outermost shell, so they become -1 charge. Okay, so the loss and gain of electron is just to maintain their stability and just to gain their octet. Okay, so if any element has one electron in their outermost shell or two electron or three electrons, so they will definitely donate that electrons and become positive charge. And if any element contain 5, 6 and 7 electron in their outermost shell, so they will receive 3, 2 and 1 respectively to become -1 charge or -2 or -3 charge. Positive charges are termed as cations and negative charges are termed as anions. The charge on any element depend on the number of electrons gained or lost. Then if you talk about group number 4, so it has maybe a +4 or -4 charge, or it sometimes share electron to become covalent bonded. Group number 6 and 7 receive electrons to become negative charge. Group number 8 elements has 8 electrons in their outermost shell, so they don't require to receive any electron or to donate an electron to gain stability. They are already complete, they are already stable, they have complete octets, so they don't need to receive or donate electrons. Therefore, they have no charge. Then charges. So you can see when we talk about charges, so here we have first group +1, +2, +3, then there is maybe +4 or -4, then -2, -1 and 0. So charge will be moved like this in the periodic table. And here group number 5 is missing, which may be like -3. If you talk about phosphorus and nitrogen, they may be formed like -3 charge. Again, group number 4 is half filled. Is maybe possible that it may donate 4 electron or it may receive 4 electron from any element, or it may be formed covalent bond. Okay, so according to the CIE syllabus, the first group, the 7th group, and the 8th group are the most important groups to study. Okay, and the remaining part of the periodic table is transition metals. So be remember, in today's class, we are going to learn about group number 1 elements, and they are called as alkali metals. And we always discuss only 3 elements of this group. You can see over here we have lithium, sodium, potassium, rubidium, cesium and francium, but we always discuss only these 3 elements, that are lithium, sodium and potassium. Okay, we just discuss these 3 elements. They are called as alkali metals because they are highly reactive. When they react with water, they will form concentrated strong alkali solution. Okay, therefore they are termed as alkali metals, as I have already told you in previous class. Alkali metals have similar physical and chemical properties because all the element has one electron in their outermost shell. So all these elements like lithium, sodium, potassium, rubidium, cesium and francium can have the same chemical and physical properties. A little bit variation in physical properties when the mass and when the size of the element will be increased, but when we talk about chemical properties, it will remain same, but a little color and a little violency in the reaction will be changed, but the reactions will be same, their balancing will be same. Okay, and their attributes towards oxygen, chlorine and water will be same. Let's start with physical properties. Okay, so here we have the first physical property of the alkali metals, or the group number 1 metals, are they are soft. They can easily cut with knife. Okay, they are soft metals. Alkali metals are the soft metals, and they are the only metals which are soft and can be cut by knife. When they freshly cut, each of these elements show a shiny and silvery surface that rapidly furnish in air. Definitely, I have told you they are highly reactive. When they exposed to air, they will react with air and become oxidized. Okay, therefore, when you cut, you will find a silvery and shiny surface only. But when you left it for a minute, it will expose to air and it will tarnish. They have low melting and boiling point. We remember this when the metals are soft, so definitely they have low melting and boiling point as compared to other metals. Okay, when we compare these metals with other metals like group number 2 metals, group number 3 metals, transition metals, actinides, lactinides, so the melting point and boiling point of group number 1 members have comparatively low, okay, because they are soft metals. When they are soft, definitely their densities as compared to other metals are also low. So the physical properties of alkali metals are they are soft, they can easily cut by knife, they have low melting point, they have low boiling point, and they have low densities. Okay, lithium, sodium, and potassium float on water because they have low densities. Now, here we have a chart where melting point, boiling point, and densities of 4 group members of alkali metal are shown: lithium, sodium, potassium, and rubidium. You can see over here, like if you talk about melting and boiling point, you can see over here the melting point of the group number 1 members decreases when we move down to the group. You can see over here the melting point of lithium is greater, but when we are moving down to the group, the melting point is decreasing, and as well as the boiling point is also decreasing within a group. Okay, you can see this in the chart. And then when we talk about densities, the densities within a group, when we move down to the group, it will increasing. Okay, when we talk about melting point and boiling point, when we are moving down to the group, it will decreasing. But when we talk about densities, so it will increasing down to the group. Okay, just predict the melting point of cesium, which is below rubidium. Cesium is the next element in the group, which is after rubidium. So we just have to predict the melting point of the cesium. How can we predict? You can see over here in the melting point that the melting point is decreasing when we move down to the group. Okay, so when the cesium is next to rubidium, so definitely the melting point of cesium will be below 38. Got it? So we have to check like this. Lithium has 180, sodium has 98, potassium has 64, rubidium has 38. It is decreasing down to the group. And cesium is next to rubidium. So definitely the melting point of cesium will be below 38. I just asked to predict. Okay, we just predict the melting point. We don't require an exact melting point of cesium. You just predict. You can predict 35, you can predict 25. It's all up to you. Okay, the melting point of alkali metals decreases down to the group. Okay, then we know that rubidium is the last member of this chart and cesium is after rubidium. So definitely the melting point will be below 38 and the exact melting point of cesium is 28. So you can predict between 25 to 35. It's all up to you. Then the chemical properties. The first chemical property of the periodic table is, of the periodic table's first group, alkali metal, is the reaction with water. Okay, before the reaction with water, we have to write some important notes on the group number 1. The first one is, these are the most reactive metal of the periodic table. Alkali metals are the most reactive metal of the periodic table. Okay, and when we are moving down to the group, their reactivity will be increased. That means francium is the most reactive metal in the periodic table, but it is radioactive. So generally cesium is the most reactive element. or metal. Okay, we have to store these metals into oils, because if we don't store them in oils, they will react with water and maybe it will be explosive. Okay, so they are such reactive metals, so we have to store them in oils to avoid exposure. Okay, each and every member of alkali metals have one valence electrons, because we know that they belongs to group number 1, and group number shows the number of valence electrons. Definitely all the members of group number 1, like lithium, sodium, potassium, rubidium, cesium and francium, has one valence electrons. Because they have one valence electron, so it is very easy for them to lose that electron and become positive charge. Therefore, they are highly reactive metals. All the alkali metals react with cold water to form hydrogen and alkali. We remember this: when any alkali metal react with water, it will form hydrogen and alkali. It will not require hot water or hot conditions to react. It will even react in cool water. You can see the reactivity by this word, that how much reactive the alkali metals are. They can even react with cold water. They don't require conditions to react. Okay, if you drop a solution, like for example, after the reaction of water with these metals, if you drop that solution onto the litmus paper, you will find that it will change its color from red to blue. That is clearly showing you that it will form highly concentrated strong alkali solution after the reaction with water. Okay, here we have a chart. You can see over here that how lithium, sodium and potassium react with water. It's very simple, because they have low densities. So what will happen? They will float onto the surface of water and react quickly. If we talk about lithium, lithium is reactive, sodium is more reactive than lithium, then potassium is more reactive. We know that when we move down to the group, their densities increases and their reactivity and their metallic character will be increases. Okay, so when we talk about lithium, when lithium react with water and when we drop a piece of lithium onto the water, so it will float and react quickly and no flame will be seen. Okay, what happened? Just lithium react with water, from highly concentrated strong alkali solution, which can change red litmus paper into blue, and hydrogen gas. Hydrogen gas can be identified by a lightning splint, and it will, if it will form a pop-up sound, definitely it will be hydrogen gas. Okay, and the reactions are same for sodium and potassium. You can see over here, sodium is reacting with water and forming sodium hydroxide and hydrogen. Potassium is reacting with water, forming potassium hydroxide and hydrogen. The reactions are same, but a little reactivity can affect the changes in reaction. Like if you talk about lithium and sodium, lithium is less reactive than sodium. So definitely when we drop a piece of sodium into the water, it will be a change in reaction. Okay, you can see over here, when we drop a piece of lithium, when we drop a piece of lithium into the water, it will react quickly. But when we drop a piece of sodium into the water, it will react very quickly. Okay, there will be a little change, quickly and very quickly. And when you drop a piece of potassium into the water, it will react violently. Okay, so here we have reactions of different group members with water. Now, lithium react quickly with water with no flame. Then if we talk about sodium, so sodium react very quickly with water. Sodium melts to form white globule. It darts around the water surface. A yellow flame is seen. You can see the changes in reaction. When you increase the reactivity of the metal, then the change will be seen. You will see firstly no flame, then when you add sodium you will find yellow flame, and definitely when you add the next member it will maybe violently, like if you add potassium, so you will find purple flame. Okay, the color of the flame will be changes on the basis of their reactivity. Okay, then they are strong or powerful reducing agents. What are reducing agents? Reducing agents are the agents that can donate their electron easily. So group number 1 member contain 1 electron in their outermost shell, so they can easily donate that electrons. So therefore they are powerful reducing agents, and it will be further studied in redox reactions. Now, do all alkali metals have the same reactivity? As we go down in group number 1, the size of the atom increases. As we know that when we are moving down to the group, the number of period increasing. Okay, when number of period increasing in within a group, so that means a number of shells also increasing. When the number of shells are also increasing, that means the size of the element increasing. When the size of the element increase, the last electron will be away from the nucleus. Okay, when the last electron will be away, it is very easy for that element to lose that electron. Okay, when it will be easy to lose electron, that is showing you the highly reactivity of the element. So that means when you are moving down to the group in group number 1, that is alkali metal, the reactivity and the metallic character of group number 1 will be increased. Okay, just write down in your copies. When we move down to the group, in group number 1, the reactivity of group number 1 members increases. Their metallic character will be increases. Okay, their melting point and boiling point decreases down to the group, but their densities will be increases. Okay, number 1, their reactivity. Their reactivity will be increasing when we move down to the group. Second one is their melting point and boiling point decreasing. Their third one is their metallic character is increasing, and the fourth one is their densities are increasing when we move down to the group. These are the trends of group number 1. It is easy to lose the valence electron when the size of the element will be bigger, so therefore the reactivity will be increased when we move down to the group. Now, properties of some compounds of alkali metals. For example, lithium from lithium carbonate, lithium nitrate, and lithium sulfate. Same as sodium carbonate, sodium nitrate, sodium sulfate, potassium carbonate, potassium nitrate, and potassium sulfate. These are some compounds of group number 1. Compounds of the alkali metals are ionic, because we know that group number 1 members have 1 electron in their outermost shell, so they can easily donate that electron to form ionic bond. Okay, they are soluble in water because they are ionic. Okay, and they have same chemical formulas. You can see over here, when lithium reacts with carbonate, it will be Li2CO3. And when sodium reacts with carbonate, it will be Na2CO3. Okay, and when potassium reacts with carbonate, it will be K2CO3. The formula will be same. Okay. Thank you so much for your time and attention. If you have any queries, so you can ask your question in the chat box. Okay, so we remember few points. Number 1, alkali metals are the group number 1 of periodic table. Okay, and we always discuss lithium, sodium, and potassium. Okay, then with these 3, we have to identify and we have to predict the other elements. Okay, then you have to memorize the trends of group number 1, and the trends are: number 1, the reactivity trend. The reactivity will be increased when we move down to the group. Down to the group means when we are moving from lithium to cesium. Okay, the reactivity will be increasing. We remember this point. It will very important. It will be very important when we discuss electrochemistry, when we discuss the other topics like redox reactions. Okay, then when we talk about melting and boiling point, The melting point and boiling point will be decreasing when we move down to the group in group number 1. Okay. Then metallic character will be increased and densities are also increasing when we move down to the group. These are the 5 friends of group number 1 members. We memorize these points. Okay. And the first point, which is related to the periodic table, is periodic table is arranged on the basis of increasing proton number, not increasing mass number. It will be increasing proton number. We remember this. Okay. And the proton number is unique for every other member of the periodic table. Got it? These are the main points that you have to memorize, and you have to remember when you are doing any question related to the periodic table or related to the group number 1.